Welcome to Lecture 8 in GRA 6036. Today is Thursday, 12th of March 2020, and in this lecture I'll simply do Project 10 that you were supposed to do in class. So here's Project 10, you'll find it on It's Learning, and before I start this project I'll go through Appendix A. Well, before you watch this video or this string of videos that I'll put out on It's Learning, I strongly advise you to try your hand at the project yourself, of course. So make sure you understand it, but you might watch this video on the appendix before you start a project. Okay, so this will be on the logical operators and or. So let's go to R. Here, so I've already written logical operators and or, and well, as you know, true has a special meaning in R. Well, true is true. You can see on my, at least on my, it comes in a special color, and you can run it, and it is true is true. Okay, the same with false. Also comes in this color. False is false. Okay, so you could also write just simply T. So T is true and capital F is false. I do advise you, however, to write it fully out, and also to avoid using a capital T and a capital F in your scripts, because they have a special meaning in R. So let's jump right in and check if true and true is true. Well, indeed it is. So that is basically the meaning of the and symbol. For this full statement to be true, both this statement and this statement must be true. Here they are true, so they are true at the same time. Okay, so it might be more natural, you can use the double equality sign to check if 2 is equal to 2, so that is true. 2 does not equal 3, so the statement 2 equals 3 must be false, and so on. I will also mention that in R you can do 2 does not equal 3. So this statement, this statement is true, okay? But in this video, I'll concentrate on the double equality. Also recall that this is, this use of the double equality is the reason for which I advise you to use the arrow when you assign values to objects. So for example, if I want the letter A to be 2, then I use an arrow. I could have used, the equality sign like this, but since one equality looks much like 2 equalities, to not mess things up, I always use the arrow when I assign values to objects, and the double equality if I want to check the truthfulness of statements. Okay, so well, now A is 2, so we could also of course check if A is 2. Well, it is. And then we could, wrap that into some parentheses and check if A equals 2 and 3 equals 3. So, well, that is true. Okay, so, this is basically the meaning of the and operator in R. So that's, the symbol for it is the ampersand, the and then we go to the or operator. So that's not as obvious notation-wise in R. So if we want to check whether A equals 2 or A equals 3, then this statement, well, will be true because we know that this is true. This is false, but at least one of them is true. So the full statement is true. Okay. If both statements were false, so if for example I changed this to equals 4 and a equals 3, then none of them are true, so the full statement is false. If the thing we have on both sides of the or symbol are true, then the full statement is true. So just try out the and the or operator in R, and you'll get the hang of it. Okay, so let's try an example where this might be useful. So in this example, I'll look at all families that have 2 children and only 2 children. Okay, so I mean a child, the gender of a child is, if we simplify a bit, either boy or girl. Okay, now let's suppose that there's a 50-50 chance each time you have a child for having either a boy or a girl. So fair coin flip. Oh, getting boy or girl each time you try. Okay, so here we have the gender, and we need some families. So let's say that the number of families, nfam here, is 1000. Okay, and then we'll make a matrix that we fill up with missing values, NA, and we want as many rows as there are families, and we want 2 columns telling us whether the firstborn is a boy or a girl, and the secondborn is a boy or a girl. So this was nfam. Okay. Then to fill up this vector, I mean, you could have a look at this vector. This is an empty, or it's not a vector, it's a matrix. This is an empty matrix. Looks like this. So if you run the whole thing, it's this thing. But this is the nice thing about using the head function. You get you don't have to print that much, and you get a certain idea of what's inside it. So here we're thinking that this, the first column is the firstborn, the second column is the secondborn, and we want to fill this matrix up with either boy or girl. So then we can write a for loop, and so now we need an index, and let's use the index I, which we used to from when we index things. When we do sums, we often use the I. I mean, but you could use whatever you want here. It doesn't have to be I. So then we want to loop I. We want I to be equal 1, 2, 3, 4, 5, 6, all the way up to 1000. So we want I to take all these values, and then families is our matrix, and we want the first column, row I, in the first column to be either boy or girl. So then we, this is a gender is a vector with boy or girl, and we can then, so if we okay, so let's move back a bit. You know how to simulate coin flips in R. So we want to flip a coin 1 time with probability 1/2. So then you get, now we're flipping coins many times, and so it gives us zeros or ones. So we could, just flip a coin here, and that will give us an index. Now, I mean, our indices in R in vectors start counting at 1. So if we add 1, well, we'll be good, because then this is either 1 or 2. Okay. Then the secondborn, we do the same thing. So we flip a coin each time, and then we want the second column to say boy or girl. So here we have our for loop, and if everything's good, we can run it. So now we have our vector with I have our matrix with families with 2 children. So the first family got boy boy, boy girl, girl girl, boy girl, and so on. I mean, you can have a look at the full thing if you want. Looks like this. Okay. So now suppose that you are told that a family has 2 children of at least one is a girl. Okay, so this you know. What is the probability of the family having 2 girls? Question mark. Okay, so I mean we can use these simulations to now you should sit down with pen and paper and draw some boxes and cross one box out and think about this. So I mean I'll hope you get the right answer, and but here we'll do use our simulations to answer this question. Okay, so let's first think about the denominator. I mean we know that the family question, a random family from this population of families, and the families we're interested in has at least 1 girl. So let's count how many families have at least 1 girl. So then we can look at the families in the first column and ask if equals girl. Then we get the true false vector. Okay, so at least 1 girl means that either the first born is a girl or the second born is a girl. So then we should use the or symbol. I mean, so this will be true. Well, here's the second born. So this statement here will be true if at least one of these, this one or this one, is true. Which means that now we'll count all the families who have 2 girls. The families where the firstborn is a girl, the secondborn is a boy, and also the families where the firstborn is a boy and the secondborn is a girl. So if we run this, we get the true-false vector. And remember that if we sum a true-false vector, the true things here, these ones will count as ones and these ones will count as zeros. I mean, that we could actually see from multiplying this vector by 1, because then you get, instead of true-false, you get 0, 1. Or instead of true-false, you get 1, 0, in that order. Okay, so we can sum this vector, then we get this number. Okay. So that is the denominator. That are all the families we're interested in, because we have from the denominator sort of deleted the families where there are no girls. So all the families with 2 boys are out. So the denominator is 748, which is, by the way, another way of counting this would be if it took n fam and subtracted all the families with 2 boys. So then we would do boys and not boys, boy and boy. So this should give us the same number. So think about that if that is not clear. Okay, so this is our denominator. Now we need the numerator. So that will be the sum of all the families with 2 girls. So then we place the or we had here with an and. So the firstborn need to be a girl and the second one need to be a girl. So this is our denominator. We can have a look at the number. It's 245. So now if we take numerator and divide it by the denominator, we get this number, so which is close to 1/3. And if you compute it correctly, you'll see that you'll know that the answer is 1/3. So we got very close. If we, I mean, it's hard to get closer, but if we increase the number of families from 1,000 to 10,000, we might get even closer. So, well, yeah, well, we're close at least. Okay, so thank you.